Hi, good to see you again. Welcome to Block 1, Constructing, Measuring, and Using Geometric Notation. Lesson 9. I'll share my screen. So, in your previous lesson, you learned how to recognize and use parallel and perpendicular lines. It's a very fundamental concept in understanding maths in the area of geometry. In today's lesson, you're going to recognize and know how to use that information, which is the names that we call different types of triangles and the properties that these types of triangles have. Before we start, remember to like the video, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. By doing that, you help us grow our mission to educate the global population of children who may not have access to high quality maths education. Before we start, I would like you to pause the video and answer the retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here you were asked which of the diagrams are triangles. These are triangles. Now you may be wondering why the others are not identified as triangles. Our definition of a triangle is a polygon that has 3 straight sides and vertices. So those others are not triangles. Next, you ask, draw all the lines of symmetry on the rectangle. The line of symmetry is the line that would split the shape into a reflection image of the left on the right or the right on the left-hand side. In this case, you have these two lines of symmetry, and you can see that here, this is a reflection of that side, and this is a reflection of the top side. Let's do our new learning for today's lesson. Alex says that shape A is a proper triangle because it is the right way up. Amir says shape B is more of a triangle because it is larger. Which statement do you think is right? Well, none. Shape A, what do we mean by a proper triangle? All right, there is nothing like a proper triangle. Okay, we need to use the right words to describe the triangle, and we'll be discussing the different properties of different triangles. And then that is not correct either. It's a triangle regardless of what size it is. Okay. Now, the properties of triangles that we know is the triangle should be 2D, it should have 3 straight sides, and it should be closed. That is why in our retrieval practice, C could not be regarded as a triangle because it wasn't closed on all the vertices. Now, something you must know is one of the types of triangles we should know is equilateral triangle. Now, here are some of the things you should know about equilateral triangles. All sides are equal and all angles are equal. So if we have one side to be 6 meters, all the other sides have to be 6 meters. And the notation we use in maths to describe equilateral triangle are these marks or these notations to show that all the sides are equal. All the angles are equal. So if you were to take a protractor and measure the angles, you would see that they're all 60 degrees. So equilateral triangle, the word equi stands for equal and lateral stands for sides or lines. So it's like saying equal sides or equal lines. Okay. Next, we have this shape here. Now, this is an isosceles triangle. Now, isosceles is defined by the two sides of the triangle being equal, and those two sides will move to the base of the triangle. The other third side is not equal to any of the other sides, and the base angles So just before I talk about the base angles, if one side is 15 millimeters, then the other side has to be 15 millimeters. But that side cannot be 15 millimeters. The base angles are equal, so they must have equal base angles. So the angles that we call the base angles are the angles that meet the base of the triangle. It is the angle that is formed by the two equal sides of the triangle. Another triangle you should know of is what we call scalene triangle. So notice that we have used different marks on all sides of the triangle. So that means this triangle, all the sides, for this triangle, all the sides are not equal. So there are no equal sides and there are no equal angles. Another triangle you should know of is the right-angled triangle. We call it the right angle triangle because of the presence of this mark. So by now, you should recognize that that is the 90-degree mark. When you see it in a triangle, that represents 90 degrees. So one angle is a right angle, and the right angle triangle can be scalene or isosceles. So we could have a right angle triangle, which is the one you see most of the time, where all the sides are not equal. Okay, they all have different lengths, but you could also have an isosceles right angle triangle where the base angles are equal and these sides would be equal. Okay, so we would call this, for example, an isosceles right angle triangle. All right, pause the video and answer questions 1 and 2 to practice what you've learned in answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. So here you were asked to classify each triangle as equilateral, scalene, right-angled, or isosceles. So this was to help you gain an understanding by practicing knowing the names and spotting what name to use when you see certain triangles. Pause the video and answer question 2 in 2 minutes. Question 2, you were asked, measure and label the angles and side lengths of the triangles. Okay, so this is equilateral. All right, so then you were asked to then classify each triangle as equilateral, scalene, right angle. So first, to measure and label the angles and side lengths of the triangle, you could use a protractor to do that. And then use a ruler to measure the side lengths. And you would notice that these sides are equal. So visual inspection can help you, but if you measure, you'll be more specific to know that this is isosceles, while this is equilateral. And here is B and C, all right, for question, yes, B and D. All right, so here you can see that this is a right-angled isosceles triangle. You can see these sides are equal. When you measure, you'll notice it. Why this is scalene? Now, sometimes we can draw triangles in what we call isometric paper. Now, here is what Jack says. Jack says, excuse me, the diagram shows a right-angled isosceles triangle. Do you agree with Jack? Of course, we wouldn't. Why? Maybe Jack was thinking about the spaces between the dots. Now you can see that the spaces in the vertical dots, the dots on the vertical axis, have more spaces compared to the dots here. So if you were to use a ruler to measure, you would see that that is actually the case. And if you measure that, you would see that that is the case too. All right, the dots vary in distance between each other. So we disagree with Jack. All right, you can see that's 1.75. All right, so that is not an isosceles. That's not a right-angled isosceles triangle. Here, Here is this statement. Let's see whether you agree or not. All triangles have at least one line of symmetry. Well, one way to prove this is to draw lots of triangles and to see whether the statement is true or false. Now, when we start to do that, you would see that something like this doesn't have a line of symmetry. This does not have a line of symmetry. There is no way you would put a line through any part of the shape where you would have a reflection of one side on the other side. But this could have a line of symmetry. All right. And that doesn't. All right. So far you have identified some key facts about lines of symmetry, about isosceles, right angle triangle. So I want you to pause the video and do some practice on what you've learned. So pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here is the answer. Okay, here are the answers. So here you were asked to draw these triangles on the grid. So by now, you should know that an equilateral triangle will have all sides. You should know that a scalene triangle will have equal sides. You know that a right angle triangle, what it should look like, and scalene, and then isosceles triangle. Pause the video and answer questions 4 and 5 in 2 minutes. Assuming you've paused the video and you've answered questions 4 and 5, here are the answers. So here you will simply ask, is Tommy correct? So Tommy says a triangle can either be right angled or isosceles, it can be both. Well, that's not right, because we did see at the start of, during the examples for the lesson that we can have an isosceles right angle triangle. This is the answer for question 5. Question 5, you were asked, Aisha has drawn a triangle inside a circle. What type of triangle has Aisha drawn? We can see that it's isosceles. You can see that these sides are equal. All right. So you could use a ruler if you had, screenshotted the sheet and printed it out, or you have the white rose worksheet. You could have measured this to ascertain or to check that it's actually an isosceles triangle. Pause the video and answer questions 6 and 7 in 2 minutes. Assuming you've paused the video and you've answered questions 6 and 7, here are the answers. So here, she says, this is an isosceles triangle. Of course, no. So you could have used a protractor to measure each angle to check. So if it was an isosceles triangle, these two angles would be equal. The base angles would be equal, right? The base angles would be equal, and these two sides would be equal. Now, here is for question 7, you were asked, is the statement true or false? All triangles have 3 lines of symmetry. Well, that's false. Only equilateral triangle has 3 lines of symmetry. Every other triangle, some do not even have a line of symmetry. And that brings us to the end of our lesson. So far, what you've learned is you have learned about the types of triangles and their properties. You have learned that an equilateral triangle has all the sides being equal, and each of the angles is 60 degrees. You've also learned that we have isosceles triangle, which has both sides to be equal and the base angles to be equal. You also learned that we have scalene triangle where all the sides are not equal. And you also have right angled triangle where there is a 90-degree angle. And you can have 2 types of right angled triangles. You can have scalene right angled triangles, and you can have isosceles right angled triangles. Well done for sticking around, for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.